Hello friends, today I'm going to solve LeetCode problem number 198, house robber. In this problem we are given a list of elements where each element represents the amount of money in the house, and what we are said here is what we are given that we could not break into adjacent houses because then alarm will uh, go on. So this means we can only break two non-adjacent houses, and doing so we need to find the maximum amount of money that we can rob without alerting the police, without getting on. So basically, in simple words, the problem statement is that we need to find the maximum sum of non-alternate elements. So how can we do that? Let's just see here. So basically, what is non-alternate elements? Here, if we are choosing element 2, then in that case the non-alternate element would be, oops, sorry, yeah, so in that case the non-alternate element would be either 1 or 3. So in order for us to pick the maximum value, what would be which of these two non-alternate elements would be picked? Well, basically 3 is the highest value, right? From 1 and 3 is the highest one, so we will definitely pick 3. So 2 plus 3 will give us a 5. What if we chose to not start from 2, but we choose to start from a second element? So we first still this house, then the alternate element for this would be the element 3. In that case the sum would be 1 plus 3, which is equals to 4. So among these two, which is the highest? Of course 5 is the highest, right? So we get the maximum sum equals to 5. Now we know like what the problem statement is and what are we asked to find out. Now let's see what other test like scenarios, different scenarios, and see how we could solve this problem actually. So we are given this example here. This is the example that I created for us to look at different scenarios that could occur. Now if we start from 2, the alternate elements would be 3 or 9, or even like 1. This 18 is also alternate, so any element other than 10 is alternate to 2. So we could choose any of the elements, any of these elements here other than 10. But we don't need to go beyond the first two non-alternate elements, because what's happening here is, let me just show you. So if we go beyond these two non-alternate elements, which means that we are directly jumping right to 18, so we are only getting 2 plus 18. So what we are missing here is we are missing something, that is 18 is alternate to 3 as well, right? So we could have jumped from 2 to 3 and then to 18. In that case our sum would be 2 plus 3 plus 18. But since we jumped, we didn't do this. In this case we jumped directly from 2 to 18. We are getting the total sum would then get less, we are getting a value less than this, right? So that is why we do not jump. We will only look for first two non-alternate elements. Now we know that we only need to look for first two non-alternate elements. Now the next thing for us to do is, now starting from 2, the first two non-alternate elements is 3 and 9. So if we do this way, like our intuition would say us to pick the largest number among these two elements, right? Because that would give us the largest sum. So among these three two, I pick 9 because 9 gives us me the largest sum, right? 9 is larger than 3, so of course 2 plus 9 is greater than 2 plus 3, so I pick 9. Now once I pick 9, then I cannot pick 18 here because now 18 is alternate to 9, so I'll have to either pick 6 or 3, which is the first two non-alternate elements to 9. In doing so, I am now missing the largest element in this whole array, so that would actually give me some that wouldn't give me the correct value. So the best way to solve this problem is not by choosing the first greatest among the first two alternate elements, but rather doing it in like other way around. That is, we start from 2. So what we do is we start from 2, and the greatest sum so far, what is the greatest sum so far? It's equals to 2, right? So the greatest sum so far is 2. Then what we do is we choose the next alternate element to 2, which is 3. So we only choose the next alternate element, which is 3, and then what we do is before choosing the next alternate element, so we start from I equals to 0, so we get the maximum sum until this point. Now until this point, when I is equals to 1, what would be the maximum sum? Well, since 2 is alternate to 10, we cannot add 2 to 10, so the maximum sum would be equals to 10 itself. So the maximum sum now I have is equals to 10. Now when I reach the second index, when my index I is equals to 3, that is when I have to find the maximum sum. So when I am at index I equals to 3, I can add the non-alternate element, which is equals to 2 here. And since 2 is the maximum so far, what I am getting here is I'm adding 3 to 2, so the value here now is equals to 5. Now I also compare 5 with the previous maximum element here, which is equals to 10, which among these two, which is greater? Of course 10 is greater, right? So I get a 10 here. Now in the next iteration, I move to 9. Now for 9, for 9 I add 9 to its non-alternate element, which non-alternate element, actually the maximum sum of non-alternate element, which is equals to 10. So 9 plus 10 is 19, and then I compare that with this value as well, so that would still be 19, right? And now what I do is, in the next step, I do the same for this element here. So now for 18, I add it to the maximum at index a maximum at its non-alternate element index. So that would be this one, because it is non-alternate right here. So I add 18 to 10, it would be 28, and between 28 and 19, which is greater? Of course 28 is greater, so we add a 28 here. And why? If you look here, this 10 actually is this value here, because we compared 5 with 10, and since 10 was the maximum, it came here, right? So this 10 is this value is actually from actually the value at this index. But if you look at this value, it is still non-alternate to 18, right? Because 10, it is not in the alternate position, because alternate to 18 would be index number this one, which whose corresponding maximum value is this. So of course we are doing the right thing. So what we do is, now we have 28. Now we move on to the next index, which is equals to 6 here. And then for 6 we find the non-alternate element, which is 19. So add to 19, which is the maximum sum so far. So 19 plus 6 is equals to 25, and 25 and 5, which is the maximum. Of course 28 is the maximum, right? So we get the value 28. And then for 3 we calculate the sum with its non-alternate element, which is equals to 28. So 28 plus 3 is equals to 31, and among 31 and 28, which is the last element here, the maximum is 31. So we are actually creating this list of maximum sum so far, and then every time we are calculating the new value, we are taking the sum with the non-alternate element, that is the second last element would be the non-alternate, and then finding the maximum between these two. So that is how we will be solving this problem. So let's dive into the coding part now. So let n equals to length, and then what we need is we need to keep track of the previous two sums, right? Only previous two sums, because we are only comparing, we are only adding an element to the sum of non-alternate element, and then comparing it to the previous sum. So previous 1 equals to 0, previous 2 equals to 0. And then we start from, okay, what we do is our previous as you look here in these two cases, for index I equals to 0 and 1, the sum are the value of the index value at the value of nums itself, right? So what we'll do is we'll just put the values of this element. Previous 1 is equals to nums 0, and previous 2 is equals to nums 1. Now starting our for loop from I equals to 2, I is less than n I plus plus, and then what we do is, now we need to find the maximum. So let max equals to 0. So what are we gonna do here is max. Yeah, so what we are doing here is, okay, let me just clear these things up. So once again, so now we have previous 1 equals to 2, and then previous 2 equals to 10, right? So we have the value 2 and 10. Now we need to find the maximum for index 3. So we add 3 to p1. So what we do is p1 plus 3, we do this, and then we find the maximum between p1 and between this value and this value, and then we store it in our max value. And then now what happens is, now once I'm storing it in max value, now my p1 becomes equals to p2, and then p2 becomes equals to max, because we are moving because we are moving, right? So 3 2 we add 3 plus 2, p2 is 2, so 2 plus 3 is 5, and p2 is 10. So between 5 and 10, 10 is the maximum, right? So max value is equals to 10, and then what happens is p1 equals to p2, the value of p2 becomes, so p1 becomes equals to 10 here, and then the value of p2 becomes equals to the value of max, which is equals to 10 itself. So that is what we are gonna do. So let max equals to, okay, let me just use max val because max is p2 plus, okay, p1 plus nums I comma p2. Is that right? P1 plus the value at that index plus p2, and then swap the elements. Now p1 equals to p2. Oh, it's previous here, so let me just use p1 and p2 here as well, and p2 equals to max val here. Alright, so our final value will be stored in p2 or max val itself. So I'll just return p2 here. Let's see if our code works perfectly. Okay, I'm getting some error here. Some wrong test cases. So I is equals to, so this here in this case p1 is 2, p2 is 1, and then for I equals to 2, nums I is equals to 1, so I'm adding 1 to 2, which is equals to 3, and then p2 is equals to 1, right? So which is the maximum value, 3 or 1? 3 is the maximum value. So so what happens here is my max value is equals to 3. Now my p1 is equals to 1 and my p2 is equals to 3. So I have 1 here and then 3 in p2. And the next case, what happens is now I is equals to 3. So 1 plus 3 is equals to 4. And the value of p2 here is equals to 3. So which is the max? 4 is the maximum value. Something went wrong here. What did I do wrong here? Okay, let's just see what's happening. So in the next case, what happens is now my p1 is 10, p2 is also 10. Now I add 9 to p1, so the value becomes equals to 19, and then my p1 becomes equals to 10, my p2 becomes equals to 19. In the next iteration I add 18 to p1, so my value is equals to 28. Then I swap 19 and the max value 28 is equals to p2. In the next iteration I add 6 to 19, which is equals to 25, and the maximum still is equals to 28. So p1 becomes equals to 28, p2 remains 28. In the next iteration I add 3 to 28, which is equals to 31, and then p1 is 28 and p2 becomes equals to 31. In the next iteration then I add 9 to 28, which becomes equals to 37, right? So now p1 becomes equals to 31 and p2 becomes equals to 37. And the next iteration I add 7 to 31, so p1 becomes equals to 37, and 7 plus 31 is equals to 38, right? And 38 is the max, so p2 is equals to 38. So 38 here comes to answer. but in this case 2 1 1 3. So what's happening in this case here? So p1 is equals to 2 and p2 here is equals to 1. Oh no, p2 here is equals to the maximum between these two values, so p2 is also equals to 2. Yes, yeah, right. So that is what mistake I did here. So once I have p2 should be math.max, every value, every element, every single time p2 is the maximum of p1 and p2. So nums1 comma p1. Yeah, now it will work. Great. Okay, it's all right. Since this is only single element here, that is why we are getting a not a number, because we do not have nums1. So how could we tackle that? Okay, so here base condition we'll write if nums length equals to 1, then return nums 0, and if nums length is equals to 2, then we'll have the maximum value already in p2, and we are going to return p2 here. Cool, let's submit this. Awesome. So I hope that you liked. It was helpful. This solution was helpful. Now talking about the time complexity, we are using a for loop, so it is O of n time complexity, and the space complexity is constant because we are not the space is not dependent on the size of the array. So yeah,